This is Unit 3, Day 9, starting off with equations of a circle. Okay, a circle is a quadratic relation whose locus definition is the collection of all points equidistant from a given point. That given point is called its center. All right, so now this is some review from geometry, and we start off with the distance formula. Okay, so the distance is basically just the difference between your x's squared plus the difference of your y squared, all underneath the square root. Another option that might be a little easier for you is to do Pythagorean Theorem. Okay, a squared plus b squared equals c squared. So if you guys kind of look at it, your radius is always your hypotenuse. So these are like your a's and that's like your b. So you could do a squared plus b squared equals radius squared, also as an option instead of the distance formula. All right, it says example 51a. So a circle is the collection of all points that are set distance, the radius, away from a point, its center. The circle shown below has a radius of 5. It told us that. So now we know the radius is 5. And the center is given the coordinates 4, 2. Okay? Using the distance formula, show that the point 7, negative 2 must lie on the circle. Okay, so remember, you're using 4, 2, which is the center, and then now they want us to test 7, negative 2. So this is like your x1, your y1, your x2, and your y2. Okay, so in order for us to find the distance, you're going to take the square root of 7 minus 4 quantity squared plus negative 2 minus 2 quantity squared. Okay, make sure you keep the square root over the top. That ends up being 3 squared plus negative 4 squared. Okay, continuing on. That's going to be 9 plus 16, which is the square root of 25, which means it has a distance of a radius of 5. Okay, so we just proved algebraically that the radius is 5. All right, so now they're saying use the point x, y, and 4, 2. Okay, so ready, square root. It's x minus 4 squared plus y minus 2 squared. Okay, square both sides, and that would be equal to what the radius is. So to square both sides of this equation, actually I'll put the r on this side. So if I square both sides, well, the right side's pretty easy. It just becomes r squared. So now when you square this left side, anytime you square a square root, it just simply removes the square root. So this becomes x minus 4 quantity squared plus y minus 2 quantity squared. And then that's equal to your radius. Now don't forget, radius squared. Our radius is 5, so it's really just equal to 25 because 5 squared is 25. Part D. Show algebraically that the point 1, negative 2 must also lie on the circle. This becomes the x, this becomes the y. So now we're going to come up to our equation that we found in Part C and plug in 1 for x. So we're going to get 1 minus 4 quantity squared plus negative 2 minus 2 quantity squared, and we're checking to see if that's equal to 25. If it equals 25, then you know the point 1, negative 2 lies on the line. Okay, so you end up with negative 3 squared plus negative 4 squared, and you're checking again to see if it's equal to 25. You're going to get 9 plus 16, and finally you get 25 equals the 25. So yes, that point lies on the line. All right, the equation of a circle. Something really, really, really important you have to realize. Okay, it says the center is HK. So from the equation over to the center, you have to make sure you realize they are opposite signs. Okay? All right, so now looking at this next question, example 52, which of the following equations would have a center? So now remember, it's going to be x plus 3, opposite signs, quantity squared, and y minus 6 quantity squared. So you definitely know it's plus 3 minus 6. So you can get rid of choices 1 and 3. All right, you could actually get rid of choice 4 too, because that has a plus 6, and by process of elimination, you know it's going to be choice 2. Okay, and don't forget, it told you that it has a radius of 3. So remember, that's radius squared, so 3 squared is 9. Example 53, for each of the following equations of a circle, determine both the circle's center and its radius. If its radius is not an integer, express it in simplest radical form. That means you have to break down and reduce that radical. All right, so ready? The center. Opposite signs. So this says negative 2, so you write positive 2. This says negative 7, you write positive 7. Remember, that's r squared. So if I take the square root of r squared, I get r. So my radius is 10, because the square root of 100 is 10. All right, my center, positive 5, negative 8. My radius, 2. Again, I took the square root of the 4 to get 2. These, you don't see numbers. So the answer for the center is 0, 0, radius 11, because the square root of 121 is 11. Part D. The center is negative 1, negative 2. Radius is equal to 1, because the square root of 1 is 1. The center is 0, positive 3. Radius is 7. Back up to the top here, part F. Negative 6, positive 5. Radius is the square root of 18. But then you break down the square root of 18 to radical 9 times radical 2, which is going to be 3 radical 2. So that's my radius. G. Center is 0, 0. Radius is 8. Square root of 64 is 8. H. Center is 4, 2. Radius is radical 20. That breaks down to the square root of 4 times the square root of 5, which is going to give me 2 radical 5. Part I. 0, 0 is my center. My radius is radical 57. Now, 57 is a prime number, so it won't break down, so you just leave your radius as radical 57. Example 54. Write the equation for circles A and B shown below. Show how you arrive at your answers. Okay, now don't forget, it's x minus the h quantity squared plus y minus the k quantity squared equals radius squared. All right, so now you have to do your distance formula, okay? But I talked about having Pythagorean theorem as an option. So if you're going to do distance formula, just do the distance, x minus x quantity squared plus y minus y quantity squared underneath the square root. I also want to show you a different option you have. You could drop this and make this a right triangle, and you're going to do Pythagorean theorem. So the x's, okay, this is always over x up y. So this bottom part represents your change in x's, or the distance, and this represents your distance in y. So how do I go from a negative 2? What's the distance between a negative 2 and a 1? The distance between a negative 2 and a 1 is a 3. So the bottom part of that triangle is a 3. Okay? The distance between 4 and 8 is 4. So my y value has a 4. Now, this is my radius. I can use Pythagorean theorem with 3 squared plus 4 squared equals my radius squared. Okay? Some of you recognize that this is a Pythagorean triple, so this is going to be a 3, 4, 5. But let's prove it with our work. So I get 9 plus 16 equals r squared. 25 equals r squared. You're going to see I'm going to stop here. Okay? If I wanted to know the radius, you square root it, and you get 5 as your radius. But don't forget, the equation of the circle is set equal to r squared. So r squared is 25. That's part of the equation right there. So now my center was negative 2, 4. So ready? X plus 2 quantity squared plus y minus 4 quantity squared equals 25. And again, look, that's right there. That's that r squared that's over there. Okay, so that's the equation of circle B. Circle A, I'm going to do the same thing. Okay, so I'm going to drop, make this a right triangle. How do I go from a 4? What is the distance from a 4 to a 6? That's going to have a distance of 2 on that right triangle. Okay, 1 to 4 on my y is a distance of 3. So now I'm going to use Pythagorean Theorem. Okay, just another option. If not, you're doing the distance formula with 2 squared plus 3 squared equals radius squared. 4 plus 9 equals radius squared. 13 equals radius squared. Again, I'm going to stop there because that's the part of the equation I wanted. But if I take the square root of that, that would tell me that my radius is radical 13. Okay, the equation, opposite signs. X minus 4 quantity squared plus y minus 1 quantity squared equals 13, because that is your radius squared. And if you squared radical 13, you get 13. Last example here, example 55. By completing the square on both quadratic expressions in x and y, determine the center and the radius of a circle whose equation is. Okay, so we're going to complete the square twice, and we have to do it to the x's and the y's. Okay, so I'm going to group these x's first, and I'm going to write x squared plus 10x plus space plus, now I'm going to group the y's, and I write y squared minus 2y plus space equals 10. Okay, if that 10 happened to be over on this side, you're going to have to want to bring it over and isolate that number. You should have only the x terms, only the y terms. All right, now remember, to complete the square, you got to take your b, you divide it by 2, and you square it. So ready, off to the side, I'll show my work. My b cut in half is 5. 5 squared is 25. So I add in 25 on the left, but I also have to add it to the right. I'm going to do the same thing for the b over here with the y's. My b is negative 2. So negative 2 divided by 2 is negative 1. Negative 1 in parentheses squared is positive 1. So I'm going to add 1 to both sides. Okay? Now I have to factor this. Okay? We already reviewed completing the square when we were talking about vertex form. Okay? So the shortcut. The sign of the b is always the sign in your binomial here. And then you just take the square root of 25 and you get 5. It should make sense. 5 times 5 is 25, but 5 plus 5 is 10. So we know we did that right. Same thing for the y's. Okay, my sign of my b is a minus. I take the square root of 1, I get 1. Negative 1 times negative 1 is positive 1, but negative 1 minus 1 is negative 2. Alright, so there's my center radius form. Now I can identify, it says determine the center. My center is opposite sign, so it's negative 5, positive 1, and I have a radius of 6. How do I get 6? I take the square root of 36 and I get 6.